Do any of you have exam this week? Any quizzes? No?
Tomorrow there is 5-7 exam.
You have 7 exam?
The 5, the
We have
business
exam
analytics,
tomorrow,
6-5,
6357.
3-5-7.
Oh, yeah. All right, yes. Are you all prepared?
The part about the cost function and the gradient, the concept part is a bit tricky.
Yeah, it is a little tricky. I mean, anything that's complex will be a little bit tricky. But as long as you have the resources, go over them and let me know if any questions.
Yeah, of course.
All right. Almost time. Other than tomorrow's exam, do you have any other exams? Any of you this week?
Not this week, but I have an exam on the 6th.
So next week?
Yeah, 6354.
Okay. And then we will also have our exam next week as well.
Yes.
Right. Hope that's not a surprise. All right. All right, so let's get started. Now, as I said, there will be an exam next week. Looking at our schedule. And so today's class will be focused on getting you prepared for the exam, and as well as to go through homework 3. As I'm sure you are working through homework 3. Hopefully you have started ahead of time and then been through them, most of them, and then probably had some questions or you wondered about some things. So we'll go through them and then I'll extend some of the points as I did, in previous classes. The session's good recorded, you can replay later. And all of these will be, somewhat linked to the exam in such a way that the exam is, well, the exam is, think of the exam as a, test of your familiarity with everything that we have covered in this class. Obviously, there are a lot. And there are a little bit of conceptual concepts, points. And those are, Ani said it's tricky. Yeah, if you don't spend much time on it, it is a little tricky, but I think the scope is still limited during the first half of the semester for this course. So there are some concepts, but there are not a lot. And the exam is open book. So, you don't have to remember all of them. The same cannot be said about the hands-on. Now we place a great deal of weight on the hands-on, particularly those points that are highlighted in the modules, as well in homework and hack shops. So those that that you see frequently over and over are those that are important. And those are important because I know that in my own work, dealing with data, cleaning, manipulating, understanding data for project purposes, those are important. So that's why they are highlighted. Everything hands-on wise, everything is geared toward practices. So so those questions are all hands-on, coding, sometimes debugging. Debugging is also an important skill in today's coding, particularly for Python and R and anything data related, because there are situations change, scenarios change as you deal with a different data set. So bugs will always appear. It's not because you're a bad programmer. It's because situations change. So it's a necessary skill in today's data science coding job market. So you want to do it well. You want to not fear errors, but find a strategy, find your habit, or develop your habits of overcoming bugs one after another. That's basically the process of my work in terms of coding process. Right. So that's the exam. Exam will be next week. Later today, I'll talk more specifically about a few detailed requirements about the exam. And first of all, let's go ahead and look at the homework 3. So I don't have any specific slides here, but when I have to draw some notes or draw some graphs on using my stylus, I'll hop on the slides presentation mode to do some drawing. Otherwise, we will mostly remain in Drupal notebook. So let me turn on my Drupal notebook. The first thing we're going to go through is homework 3. Now, this needs no it doesn't need me to repeat, but just want to emphasize that this course is reverse classroom, meaning you guys do a lot of self-paced learning. As long as you are up to pace to the course, you do a lot of learning, exploration, trying different things by using module resources as well as the videos. And then when we join in classes, which doesn't join every week, but so far every other week, seems like, we are going to look at cases, and the homework questions and hackshop questions are specific cases. Through those cases, we talk about different techniques, different issues in depth, expand it a little bit, so that what you learned can be put into real practice. So, I repeat this before, I'm sure, but just to make sure that things are clear. So I will turn to my homework 3. I'll go through homework 3 questions as you are working on it. To the deadline is this Saturday. So let's do. Can you all see the Drupal notebook? Homework 3.
Yes.
Yes.
Great.
Yes.
Great. Now, before I get started, do you have any questions? So let me know which questions which problems you have questions about. You plan to ask me questions, or you plan to pay close attention to those because you have some questions or you have some issues, difficulties. I like to get a sense about where you all might have questions. There are 13 questions here, problems. Which of these have you had questions if you have started? Anybody?
I do have a question, Professor Ma. So
Yeah.
for question 11, the result I got has some NA value. Is that normal?
Can you say that again?
So
Question 11?
the results I get after using the concat, there's
The results?
yeah, the results got some NA values.
Okay. Yeah, that's a good question. And in data science and particularly in this course, you're going to see that a lot. And then you'll become comfortable dealing with them. And of course, not fear when you see them, but then develop a strategy of understanding the impact of those and then how to deal with it. And then when to expect to see them, and sometimes they show up unexpectedly. In those cases, you want to pay closer attention to, why, and then find a solution to deal with that. Here, some of them are intended, and you actually want to see some of them, but in specific places. You don't want to see missing values in places that you don't expect them to show up. But this is one of the, I think question 10 and 11, they are connected at some level. So yes, you will see, and I'll talk about that specifically when we'll talk about this question. But great.
Thank you.
Anybody else have other questions? That you would like to, hear me to spend more time on some of these questions. All right, that's fine. As we go through, I hope you remain engaged with me, and then answer questions if I ask them. I like to poke around. I will try different things, and then I'll ask you about what you would expect about the outputs. And I hope you, answer those questions, say it loud. Feel free to unmute yourself if your background is quiet. It's fine remaining unmuted as long as your background is okay. But when you want to ask a question, don't forget to unmute yourself. Okay. So let's start from the beginning. Right. After you download homework, don't forget to rename the notebook. So I'm saying slideshow because I modify some of these for the purpose of class. But whatever the name is, yours, go ahead and add your name after homework 3, but don't include the brackets. Other things are more routine. Okay. The first question is more of a, kind of giving you the points question. And I've already put the answers here. Import pandas and numpy. We import pandas, numpy as NP, PD and NP. And then also import NA values because we are going to use NA value more extensively in this course and in this homework. It is fine if you spell NaN in one of these different ways. Let me run this first. Okay, and then there is, let's see, numpy. There is a missing value simple or Sentinel with the capital letter N's, that is fine. With all lowercase, as here is imported, and then I think there is a all capital cases as well. So one of these, all good, but there's nothing that spells as this, and then capital first letter, that is not allowed. Okay, so one of these three ways, they are fine. And okay, question 2. Reading this data set about MPG, about cars. I'm sure some of you here are into cars. Me, at some level, not too much, but you know, the mechanics side, a little bit interested. But this data set is about the MPG fuel efficiency. All of these are gas cars, and from old time. So it's not a super new data set, but it's a good data set to practice with. We have a sample of a few hundred cars, their make and models, their different properties in terms of features, mechanical features, and then the fuel efficiency, MPG. The data set is that. I recommend working with, before you start working on any new data set, here, import the data set. But before you work on it, look at the information about the data set. Don't just start doing the homework, because understanding the data set a little bit better rather than going blind is going to save more time later on when you start working on the data set on some of these questions. Some of the questions get deep, and you know, rather than going back again and look at it, you know, spend time sort of when you are confused, you started looking at the data set information again, you get more confused. So it's good. It's a good practice to take a fresh look before you start doing these questions. And then, of course, some of the hands-on help you understand the data set as well. And some of the questions are those kind of tasks that you want to do as you start understanding a new data set. So the question is designed in a way that it kind of teaches you or transitions you into knowing the data set a little bit more. But then it quickly becomes deep again, some of these questions, so that it requires you to have a good understanding of the high-level structure of the data set. So let's go ahead and turn to the information about the data set, which is so let's see how we do it. So I have a, okay, why don't we do this? I'll share the specific window. This is about the MPG data set. Will not show that window. Now, do this. Share this window. So this is the MPG text file for documentation for that data set. You can download it on the Blackboard. In this data set, there are 398 rows and 9 columns, including the categorical variables and a text variable here, string variable. The most important column here is perhaps the MPG. It has a continuous type of value, and it has these other features, function, mechanical features of the vehicle, the different vehicles, and there's a name, make and model, basically, of the car. And you notice that most of them are continuous type variable, which means interval, which means numeric. And the values, the numeric values means numeric. You can do additions, you can do subtractions, you can rank them. But there are 3 variables here that are categorical. This categorical variables sometimes are described as multi-valued discrete variables. Discrete means unique levels. You know, like men and women, you can't rank them, you can't calculate plus and minus in any meaningful way. You can only subjectively rank them or arbitrarily rank them, but they don't mean better or worse. So categorical variables are like these. But sometimes you also have those variables that are rankable, but not, differentiable. Cylinder here is one good example. Model year, model year is kind of a unique because it's a date variable, date or year variable. It's a time variable. And then origin is more typical, more of a typical categorical variable. So a few more things have to be said about cylinders in the model year as categorical variable, but when we get there, we'll talk about that. So this is a good amount of time to spend on the new data set, since this data set is fairly small and easy to understand. Okay, then it's time to come back to the homework. Okay, I have imported this data set. Now let's just quickly go through some of these questions to understand the data set further. Answer the part 1 as a question. At the first 3 rows of the data for a quick visual look at the columns and values. And I trust that everybody here is familiar with how to do that. So I'm just going to do that. And you see note what do you call it? Eclipses here, which means there are no columns omitted. All the columns are displayed with only 3 rows on the top. And quickly confirm, you see numbers all through, except for the brand model or the name variable. It's called interesting. The text file says it's car name. Here the actual column name is brand model, but it's understandable that they mean the same thing. Okay. The origin means the country, the place of manufacturing, I believe. So, whether or not it's foreign made or domestic made, and where was it made? Where is the location of manufacture? You would expect that the values are names of the countries, or maybe continents, or differentiating domestic versus foreign or imported, but here it's numbers. So, I would wonder, as I start to understand a new data set, I would wonder how many origins are there, right? Based on 3 rows printed data, it's hard to really know, but it's quick to know. So I'm going to do some demonstrations as, because this is, part of my habit. When I try to understand a new data set, I will do these different things because I think the time spent, and I'm interested, I'm curious. So the time is well spent, even if it's not really answering the question. And keep in mind that you don't feel you don't have to include this, right? And maybe it's a good idea to also remove these cells after you have done explore, as I would do. But you don't have to include these because these don't answer the question. Only include the codes that answer the question. That would be the best way to go for homework. But since I'm here, I'm going to take a look at the origin column. Now, I'm using the dot method to refer to the column. There are different ways to index a column, as we talked about in the class. And this is a rather clean way of doing that, is using the dot, sort of like dot attribute way to refer to a column, which Python understands that pandas understand that I'm trying to get the values and the metadata of this column. So what I get is a series in the end. So same way, or same result, but different ways of indexing the column. I'm accessing the column, and I'd like to take a look at the different values and then rank them based on in descending order of number of cars. So origin 1 is 249 rows with that value. There are 79 rows with origin 2, origin 3, and 70 rows with origin 2. So there are only 3 different countries, let's say 3 countries. These are the cars from the 80s and 90s, maybe even 70s, because there is a manufacturer year, model year. That's a model year, meaning when was the model initially launched, in the 70s and 80s. So these are not modern cars. There's no Tesla here, as you know. So what would you guess as the value of 1? 1 refers to a country. Which country would you believe 1 represents? And we have some hints here. Buick, we have Chevy, so anybody can tell me what 1 stands for as the country of origin.
US.
The US, yes. And the US produces the largest number of models, not only brands, but models, in this data set. Now, the other 2s are harder to guess, I will say. What would you say 3 represent?
Maybe Japan.
Take a guess. Japan. I would go for that as well. And let's say that, or anybody has a different opinion, welcome. And moving on, what would you say 2 represent?
Germany?
Germany. Yeah, it's either Japan or Germany, 2 or 3, right? So the moment of truth, let's take a look. So here, purely driven by my curiosity, I'd like to know what 2 or 3 might represent. How do I know that? I can take a look at the data set and then look at the brand models of those cars that have an origin of 2 or 3, right? How do I go about it? I know that the first 3 rows do not qualify. I can print the whole table, which, it's not fun if I print the whole table. I know that I'll only get to see the first 5 rows and the last 5 rows. All the other rows are omitted because it's too big to show everything. So what I want to do is I want to slice, or I want to index only those cars that has an origin of 2. This will require you to use a what we call an indexer, a selection mechanism, a filtering mechanism, if you will, but we don't use any filter methods. We use a technique. We use an indexer. So here is what I will go with, and this is what I do always in my own work with data. If I want to look up something of this nature. So the task is to select, or let's say filter, or show rows, cars with origin value of 2. Let's do that. I will need a indexer. So IDX, I will create an IDX for origin 2. I'll give that name, which is meaningful. And this is not really necessary, but I'm taking several steps. I'm doing several steps one by one so that you can see the logic, and later you can put them all together in one line when you're familiar. But what is an indexer? Here I'm going to do a Boolean indexer, which means it had values true and false. And then when used as an indexer, it will select those rows that correspond to the true value in the same position. Okay, so I'm going to have to refer to the origin column again, and then I'm going to compare that to value 2. And I confirm that, why do I use 2? Why don't I use string 2? I have to be sure that it's number, right? So by convenience, I have these outputs, and I confirm that the data type is integer, so it's safe. So what I'm doing is I'm using a comparison a comparison command to compare the value to a scalar with a series, and then it's going to return a series with me with the same size as the column, but then the value of that series is going to be true or false. True when the origin is 2, false when it's not. And then I assign that one to an index, an indexer. So if we take a look at this, we'll see true or false. So if I try to print the whole data set, like one of the sort of uninteresting ways to try to take a look at those cars with origin 2, I might be lucky, I will see one of them, and then I might be able to quickly figure out. But as I said, that's uninteresting. What I'm doing is more interesting, so I'm going to keep going, right? So anyway, when I have this indexer, I'm then going to use that to slice into my MPG dataset. Now, with a Boolean indexer, you have to use .log. And then this indexer will need to be put in the, you know, there are two dimensions. In the dimension where you put the slicing notation for the rows, so that it's filtering the rows. So when you use lock, you know that you cannot use the index positions to select the columns. So you have to spell out the specific columns here. Now, either I can get all the columns, that's fine because there are not many columns, or I can specifically show the brand model. Excuse my son, he's trying to find his mom. Anyway, so all right, so this is one thing you can do, or you can, you know, lose the list because there's only one column, or if you really want to make sure that this works, you can select origin as well. So take a look at this complete command here. It only does one thing. Here, it uses a lock slicing mechanism to slice both rows and columns. The rows that are sliced, the rows that are selected will be only those rows that correspond to a true value with the indexer. Now, the length of this indexer has to be the same as the number of rows with the data set, but we know that because the indexer is created by comparing one of these columns with a scalar. So I know that I have a same length object, and then I know that I can use that as a indexer. For columns, I'm getting these two because for this question, for this task, I'm only going to take a look at the brand model. Now, I'm going to get 70 for here. For origin of 2, I'm going to get 70 rows. I'm not going to see all of them, probably, because that's still too much to print everything. But again, I will see enough. All right. Now, you tell me what what country is for origin 2.
Germany.
Yeah, you guessed right. So, you know, Japan still makes more cars. I mean, I guess brand models than brand and models than Germany, even though Germany is very good. All right, great. So I hope this exercise, you know, informed you a few more techniques that I personally find it very useful. I'm able to use it by typing blindly from scratch because I use it so much so that if I remember it, I'm just gonna, you know, use it very effectively. I don't have to look up my notes every time. But I'm sure the same will go with you. If you use it so often, you're going to remember how to use it. Okay, but anyway, so let me clear these. And I don't doubt that value 3 is Japan, but you know, I will leave that exercise to you offline. So try to select either all of the rows or some of the rows with origin value being 3. So do the same exercise by only changing the values. Okay, clear these cells. Okay, question 2, get the number of columns and rows, use only one line of code. This is referring to an attribute of the data frame. It's the shape attribute. Shape. By running this, you are not running any I guess manipulations or what. You are simply calling, hey, what's your name? Or hey, what's your what do you have in your pocket? How much money do you have in your pocket? So it's a simple return of the attribute of the data frame object. So it's not running any calculation. But anyway, So this is your answer. Get these. When a question asks you to get these by using coding, you only need to code it. If the question asks you to modify, then you probably want to want to assign it to something. Maybe assign it to the original data frame. Later, there's a question about replacing missing values. You will need to assign it back or change it in place, specify the parameter in place. Otherwise, the original item did not change. It's only the output that you see that was changed. Yeah, that's it. Okay. Study the column horsepower. There's a value there, question mark, and then ask you to do something. So study the column horsepower. How? How do you study? Horsepower is not one of the variables that says multi-value discrete. So horsepower is very likely a numeric. It's an interval variable. The numbers run freely. So when you try to understand an interval variable a little bit better, what will be the best strategy for you? You can print a few more rows. Like here you can see 3 rows, horsepower, 1 to 30, 1 to 65. These are pretty small. At that time, in the 70s, when yeah, the horsepower is not big, but these are interval variables. So typically with interval variables with real life data set, it's distributed fairly normally and symmetric. There may be a tail, but the mean and median will be centered around somewhere in the middle. And then you have one mode, one height, one peak as well. So that's that. But the question says there's a question mark in it. So out of some of the rows in the data set, there is a question mark. If I want to know how many question marks are there, and question mark is quoted because it's a string. Okay, so and because of that, because there are some rows that have question marks, the data type of this column changes significantly. And this is because Python uses the same data type to allocate spaces and store values for every value of this column. It has to use those formats, those data types that can store more information if needed, even if only one of the rows of this column, even if one of the rows, one of the cells of this column requires more storage, Python will have to allocate the more complex data type. So the fact that there is at least one question mark in one of the rows for horsepower, then horsepower variable column here in the data frame, its data type has to change. So to study this column, the first thing, other than taking a look at the distribution, maybe to understand that numeric aspect of that variable is perhaps to take a look at the data type of this column. To do that, check data type of a column. Horsepower. To do that, you're also calling an attribute. So either you print the data types of all the columns and look at the one for horsepower, or you simply zoom into horsepower. I'm using the dot index method again because it's convenient. I have access to all the methods of the column by using this way, so no difference with the other other ways of slicing the column. The D type attribute is going to call the type of the data type for that column. So you see an O. What does O mean? O means object. An object typically means it's a string column, even though horsepower looks like it's numeric, right? It looks like very much numeric, but just because there is at least one string value, which is question mark, in this column, the data type has to be modified by Python. So Python use the string type. String type is the ultimate freestyle, because anything it can be a string, but not everything can be a numeric type, floating type, right? If you don't believe me, let's print the data type of another variable that looks very similar. Weight looks very similar. There are numbers. Horsepower also look like numbers. But I know that weight doesn't have any missing values, or doesn't have any missing values are fine. They don't require too much spaces, memories. But question mark strings require more memories. If I look at the data type of weights, you'll see that it's integer. So even though they look very similar, they fundamentally store information differently. All right, so now that we know that it's an object type, then if I want to know how many question marks are there before I go ahead and then replace it, because of several reasons, which will become more obvious later on. So first of all, I would like to know, as part of the curiosity as well, I would like to know how many values are the same as the question mark. Okay, so how do I do that? I'm going to use a comparison, which basically I use this a lot, and I'm sure other programmers use it a lot because it's super convenient and clean and useful, and has other uses. But I compare a value, which is a scalar, with a column, and then I get one column of true or false, Boolean column, Boolean series, and then I use methods of that series to calculate statistics that I want. Here, what I want to know is how many question marks are there? Tell me how you would go about that. How do you quickly get a count of how many question marks are in this column?
Can we use the same function look for that with an indexer, the same as?
You mean lock?
Yeah, with an indexer.
Okay, so think about it. So lock is a slicing, an indexing or slicing technique. So you would you use lock to select rows and columns of a data frame or a series. For series, you're selecting rows. So I'm trying to get a count of how many question marks are there in this column. I don't really want to see those question marks, but I guess that's one way to get there, but it's not really what I want. So if you get all the question marks and then do something to calculate the number of question marks, you're doing a little bit extra. It's good if you get the ultimate information, but if there's a better way, you will want to use a better way that goes directly to how many question marks are there. So think a little bit more. How would you?
Is there a count function, count, and then add between the parentheses like string question mark?
Count. Interesting. So where did you study count? count is available to list. I think we did, what did we do? We did a string ABCDE that count how many A, there are 1. So this is a string value method count. And of course, strings are like lists. So if I make it a list, this becomes a list, and then count A is also 1. There's 1, but there's no AB because now it becomes list. So anyway, this is playing around, but if I do AB, there's 1. So, lists and strings. But here we're dealing with series. So do series have counts? Series have or data frame has a long list of methods. You can try it. The horsepower is the horsepower. Yeah, count. There is a count. Great. So if I'm counting the number of question marks here, it is a string value. You cannot leave it. You cannot leave out the quotes. That simply won't work. You're trying to find question marks as the string. How many are there? It does not work well. Requested level does not match index name and none. I have no idea what this error is talking about. So the likely scenario here is the count method for series or data frame is not the same as the count method that you're familiar with. So spending more time and digging around, a useful tool is Google, as you know. If you look at pandas, these are all official information. Pandas data frame or pandas series count, you will find that count. And then you read more to understand what this count is really doing. To save a little bit more of your time, feel free to explore, offline about the count method. I personally don't use that count too much. Maybe it's something of a surprise. Maybe I should look into it as well. But for now, I have a way that quickly helps me do that. And I return to the same technique here, if you remember. Oh, I removed that cell. But anyway, so what I do is I compare a series with, this is comparison, double equal sign. I compare it with a string value. This is a scalar. So what it does is, this is like broadcasting. Remember, we talked about broadcasting for arrays, for high dimensional data objects. When you do operations that involves things of a different dimensions, here one of this is scalar. It's going to broadcast the comparison to all the values to do item-wise. So that is what it goes on. It's intuitive to say, if you were to compare a multi-dimensional object with a single value, obviously they're different. They have different dimensions. So the only meaningful way to compare is to compare each of the value of the multi-dimensional item with that single value and give me the result of whether or not the value at each place is equal to that single value. So it gives me a same structured multi-dimensional item, multi-dimensional data with only true or false inside, indicating whether or not the original value is equal to the question mark. So here it's a column. The original column is a column. When you compare that to the question mark, it's going to return to me the same length series with values equal to true or false. And true indicates that the original value of horsepower is actually a question mark. Now, it's not enough to just do this. After that, because this whole thing is a series, then I can invoke its method and think of it as a theory. Think of it as my series is this, and then I use the methods of here. But as you become more familiar, as I do, I will typically simply add a pair of parentheses and then to invoke its method. Since I have the Boolean column and true means yes, it equals question mark, what I want to do is to count the number of true. But here, again, I'm not using count because count doesn't do what I intended, what I wanted to do. What I'm doing is I'm summing over the true or false, and the number I get is the number of trues. So if I do sum, beautiful. So that is what I need. Look at, the short line of code that does multiple things here very elegantly. You can learn this to do things very efficiently for you. So this is what I'm getting. There are 6 values of question mark. Yeah. And I compare the original column with question mark, treat it as a series. It is a series, and then quote them, not quote, sorry, use parentheses, and then to invoke a method to sum over all the Boolean values. I get 6. I get 6 total question marks. To confirm this is correct, to confirm that there are actually 6, I want to actually see it. How do I see it? Use the same technique I just used. Make an indexer, question mark for, let's see, no, this is horsepower question mark. Okay. So indexer for question mark, if I equal this to the assign that to that, then it gives me an indexer. Then I can use what Honey was saying. I can use .lock. So my MPG .lock use this indexer for question mark in horsepower, and then I take 2 things. Let me take the brand name. There's no brand name. There it is. Brand model. And then I look at the horsepower original values. And then I should expect 6 rows, 2 columns. Brand name will say the brand name, but the horsepower will all be question mark. Beautiful. And then you can see the row indexes here as well. It's, as I said, it's strongly index enforced. The rows have their own row indexes and column indexes that go with them, unless you reset them. All right, so I demonstrated the same technique 2 or 3 times. Hopefully, that is going to be helpful in the future, mostly. But anyway, so I know that, and I calculated. I want to get back the cells that I just deleted. Let me redo, undo, delete. Okay, great. I want this to be here. This confirms that there are 6 question marks in horsepower. Now, the question asked me to then replace a question mark with missing value that we imported just from above, with this missing value to denote it as true missing value that Python can understand. And then after replacement, so what happens is missing value doesn't have its own data type. Missing value can be of any type. It can be because it's like nothing. There's nothing there. There's a notation, but there's nothing there. So it's flexible. So after replacing the question marks with missing values, then all the values other than the missing values in horsepower column are numbers, and then we can convert it out of string type or object type and into a numeric type to be more consistent with the value of the column. So that's the objective of this part of the question. So replacement first, and then casting. to flow. There are two ways to do the casting side. But replacement first. Replace question mark with NA. Okay. There's a replace method. You know, I believe that you learned in the module, so we can do that. There are several ways to do. You can do it more on the target. You can replace my MPG dot horsepower as you can replace the values and then assign it, replace values of the column only, and then assign the values of the column after the value has been replaced and assign it back to the original column. That's more targeted. That is more kind of manual. It's that, you know, it's a manual process. It's hard, it's a little bit hard coding, not too much, but that requires you to know the specific information. Which column has the missing value and which specific value to replace. Oh, here it's replacing missing values, and it says replace with missing value. There's one way. Anyway, so what you want to do is to call the replace method, and the same way to access the column again, and then you can access the replace. Okay, the replace function. There are several different ways to do that. Here, since you know the value, or since you're acting on the specific column, I believe you use the value parameter and then give the original value and then the new value as a dictionary. I think. Let me double check. But anyway, I'm going to try that. I think, yeah, my memory tells me certainly right. So the specification here is to use a dictionary to give the original value that you want to replace as the key of the dictionary, and then to give the replacement value, which is NA, as the for the value of this dictionary. So this is a key value pair, a pair of, you know, just like dictionary or just like key and lock. You use this, and then Python will find question marks in this column, replace it with NA, and then, but in cases where the value is not question mark, it does nothing based on this specification. So this part is going to return the column with only those values of question marks being replaced. Other values remain the same. So this is sort of the replaced, you know, the values already after replacement. Then what I do is I assign it back to the original column. And then after I do that, I'm going to confirm by doing this again. Compare it to question mark and then calculate the sum. While before replacement, there are 6 values. After replacement, I'm expecting it to show 0. There is some issue here. Let's see. Value. Maybe it's not value. But let's see. Let's take a look. The
Yeah, Professor, for replace, I just did dot replace and then question mark in quotes, comma, and A, and it worked for me.
Still in still in curly braces, right? Or without
No,
the
not curly braces. Without the curly braces and without the value. Yes, like
That's
that.
it?
That's it.
Okay. Before I do that, I'm sure that, you know, that at least that didn't show the error, right?
Correct.
I'd like to talk a little about that. First of all, why I got this value, why I got this in the first place. To isolate the issue, comment that out, and then rerun again the same issue. So it talks about regex. Let's see, question mark. So that is going to that's getting into a territory where things get more complex. But question mark itself is, you know, is one reserved symbol in regular expression. And then here, because of the misspecification, somehow the Python thought I was doing regular expression. So the problem is mostly with this. If I remove this, problem goes away. And then if I rerun again, there's no missing. And then, but when you rerun this again, it's also going to show 0 question mark because the horsepower original column has been replaced. So to get it back, we will run the original row and then run this line again. There are 6 question mark. But then after you run the replacement, it's 0. So this works. This works as a preferred method at some level. Then what's the name of a student who just spoke? Tell me your name.
Sabrina.
Sabrina, great. Great job. You're quick to explore a solution that works, or that might work. But let's look at them.
Okay.
So what was I saying? At least, so I like to look at what was really going on. So in order to do that, I will need to look at the information, the documents for this method, the replace method for Python series. So because it's a series, I'll open up series and look at the replace method. And then typically the first one is the latest documentation for Python. And it's maybe a little bit small. So to here, originally I was specifying value, right? And then it didn't work. When I removed that, I provided the same thing, provided a dictionary. And then without the keyword specification, it's actually specifying to replace. And that is actually right. I should have specified to replace. But, you know, if you program a lot, use different methods, and if you don't use this particularly very often, you're not going to remember the specifics of these, right? But it's good to have them, you know, always available. So let's take a look. To replace, what should you provide? You can provide many things. What I did is a dictionary. So what I did is I provide dictionaries of value, key value pair. The key is the original value, the value, key and value. The value is the replacement value. So this does the job here. However, value, what does value mean? If I were to specify value here, the value should be the value to replace any value matching the to replace. So if I want to use value, I will also have to specify to replace. So this goes back to what Sabrina was saying. This mechanism, if I only provide 2 things instead of 1, but that one thing has multiple elements in there, that's a dictionary, right? But here if I provide two things, the first is going to be assigned to the to replace, and the second parameter is going to be assigned to the value. What is to replace? To replace is the original value. Value refers to the replacement value. So we're saying find all those question marks and then use NA to replace. Beautiful, right? And I don't know if coincidentally or not, it works very well. However, if you switch around, it's not going to work. Because the first one has to be the original value. The second one has to be the replacement value. But are you at the mercy of the designer and then you just have to test your luck? Of course not. So the better practice would be to most of the time for you to specify out your parameter. So if you do this, it's going to work. And then, you can try that wrong from the beginning and it's going to work as well. And even if at this time you switch over the places, it's still going to work because this time you're assigning parameters to specific parameters. It's not going to be confused. So this is the better practice. Okay, but what I want to say is this solution works if you are only replacing values in just one column. If you're replacing or if you and or this method works well. One line takes care of all if you're replacing one value in one column. However, there are situations where you want to replace values in multiple columns, and also in multiple columns, the replacement values are different. So it all depends on which column are we talking about and which value are we talking about. So in those complex situations, that's where the dictionary comes to rescue, because with dictionary, you can have very complex structure to specify, custom replacement mechanism. I will save that to another lecture. If you are interested, I can spend a whole day to show you different examples, but let's save that time here. So for this, we've confirmed that there are no question marks left, and the replacement works well. Great. So after that, we'll still have one thing to do. After replacement, we will need to cast the value type, the data type of the column to float. I mentioned there are two ways. I'll quickly show them all. So regardless of which way, friendly doggy is saying hi and saying hi back. Hope you enjoy my lecture. Anyway, so regardless of which way you do not forget to assign it back. Do not forget to assign it back to horsepower.
Did you get
So,
the bird?
I will have to unmute Campbell's friendly dog here. Because, okay, thank you. Unmute it. Anyway, so do not forget to replace back. So my horsepower is assigned with my MPG dot horsepower dot S type. Do you remember? Call the column and then call the S type. And then here it's asking for float 64. It's quite specific. So you want to do is to call the NumPy float 64 data type specifically. And then after that, confirm that it's changed, right? So that's one approach, but let's come back, run again, confirm there are 6 question marks. Replace the value. It's still object type, but there's no question mark. Only now can you do that. Only now can you do that with this as type. Otherwise, it throws you an error. A second approach actually doesn't require that. So a second approach is a completely outside the box approach. The second approach uses the pandas method as sort of a bonus demonstration, if you will, not strictly a perfect solution for this question particularly, but it does the job. It does the whole thing in one step. What it does is, let me reverse the data set, and then now there are 6 question marks, I know, without changing the question marks, without replacing it. This second approach uses pandas.to numeric function. What it does is it tries to convert values of whatever, either a data frame or a series, a column, convert everything into numbers as much as it could. But when it meets challenges like question marks, it asks you what to do, and you specify what to do up front. So I'll quickly let you see, since it's a pandas method, it's a pandas function. It's not a series method, so you will not find it here. You'll have to search Google again for pandas. So here, pandas to numeric, give it the data, and then specify what to do when there's an error. So when there's an error, you have 3 options. Raise is the font. It will raise an error telling you it cannot be done. Let's take a look. So if we accept the default, and then I use the pandas.to numeric function to convert everything in horsepower into number, because it's to numeric. It sees the question marks, it's going to throw an error, because it says, when there's an error, throw the error, raise an error. That's the default specification. However, if I choose coerce, then it's going to convert all those values in, values that are not able to be converted to numbers to be NaN. And isn't that what the question asks for, right? So what you can do here is to specify errors and specify the coerce, then it will do it. So if I run this line, it's not going to change the actual data type of the horsepower. Why not? Even if it will run, the data type is still objects, even if it ran without an issue. What is the problem? What is the reason that horsepower data type is still not converted? Anybody can think of why?
Because NA is not numeric?
NA is. And remember what we did previously is we replaced question mark with NA. NA is the same as NaN. They are basically the same thing with NumPy. And previously we replaced the question mark with NA. Here, what it does is also, since question mark is the only thing non-numeric here, when it sees question mark, it denotes an NA. It basically replaces with NA and converts all other integers into floating number. And then it does the same thing actually as this line, even though we're using totally different mechanism. But still, why is the horsepower original column data type not changed? It's still showing
Yeah,
object.
default
Because we
value
haven't
is one.
assigned back.
I haven't assigned it. This is a very typical rookie mistake. So I want to highlight it. So what I should do is do this, and then that solves the question. You see the effect immediately. The data type is converted to a float 64. This is coincidence, even though I didn't specify to be converted to float 64, but it does. Mostly because there's a missing value in there. If there's no missing value, if it's all integer, it's going to be converted to integer because integer data type saves computing space, saves memory. But as long as there's a missing value, then Python will decide to use floating point. So this is the second way, although it's not a standard way because it didn't replace explicitly the question mark. So, but in other situations, this technique might be helpful to you. So, record your first version in your homework, but then in your notes, make notes about the second version. All right, I'll quickly go through the rest here. Get the data type each column after replacing the horsepower. So it's going to give me mostly numbers, a one string column, and then specifically you want to check that horsepower is numbered, it's numeric. So this is get D types, it's getting the attributes all the way through. There are numbers, some not integers. But then brand model is object, which means strings. Question 5, use one command to get all the common statistics of the interval variables. This is going to be the describe method, mympg that describe. Often I suggest that you also use round to not print out too many decimals because they literally don't help for reporting purposes. So, and that's good. This is what you need. All these are numeric. Even though some of these are better understood as categorical, we'll talk a little bit more about cylinders, as I said a little bit later on another question. But all of these are recorded. All of these, except the brand model, they are recorded as numbers. So they will show up in the descriptions, in the statistical and descriptive statistics. The last question asks you to study the categorical variables, right? And now here, you want to zoom into the variables that are better treated as categorical, multi-value discrete variables. For each of them, get the unique values. There are 3. And let me just say that up front here, 3 categorical variables. There is a origin we just talked about, easy to understand. There's a cylinder and something else. Model year. Unique. Okay. So to get we looked at the origin values already. To get the unique values, you call the value counts. Right, so my mpg dot, I'll skip the origin because we did already. But my mpg dot cylinders, there's a plural. Cylinders dot value counts. Oftentimes I will also sort index, but I will always look at it before I decide to sort it otherwise. The default sorting will sort by the counts. inversely, so in descending order, showing the most important value category for cylinders. 4-cylinder car is the most common, more common in Japanese cars, less common in American or German cars, as you would understand, but 8-cylinder cars are also quite a lot, and 6 as well. This data set is skewed toward American cars, so you have more 8-cylinder cars, which is not that typical. Anyway, you also have 3 and 5 cylinders as sort of the more innovative or unique models. But anyway, if you want to sort not by the counts, but by the index value, which means by the values, these are the index values of this series, right? If you want to sort the report by the cylinder count, starting from 3, 4, 5, 6, and 8, you would do sort underscore index to call that method again. It's not a method, it's actually an attribute, simply, you know, just calling them by, I think that's, oh no, you have to call it. Okay, you have to call it, it's a method. It sorts the results by, because this whole thing is a series, sort index is simply a method of a series. Any series have that, not just this one. Okay, so for cylinders, and you can do that for model year as well. I think there are quite a lot of model years. Let's take a look at the minimum and maximum. Minimum is 70, maximum 82, not a lot, 12, 13 years. So it's definitely the old cars, antique cars here, but you know what to do, right? Okay, for cylinders, now it's a good time to talk about why it's better treated as a categorical variable. Even though it's numbers 3, 4, 5, 6, 8, it's numbers, it has a small range, it has a small number of unique values. And you have heavy concentration on some of these values. It tells you that these different values are different, not just because they are plus or minus 1, but they indicate very different designs of the car. And also because there are only a few possible values, a few unique values of this variable, it's better treated as categorical when, especially when you are modeling. But it's fine if you, when you're modeling, when I say when you're modeling, I mean when you are doing, when you're building machine learning models, and then you are using this variable cylinder as an input variable, it's better treated as, you would gain more insight if you treat it as a categorical variable rather than a numeric variable. That said, in other exploratory tasks such as correlations tables, because it's so cumbersome to make make any kind of correlation reports with categorical variable, here you want to actually treat it as an integral variable when you do the correlation analysis, because still these values, the number of cylinders, it makes sense when you do additions and subtractions. It still makes sense. It's ordered, it's rankable. It's even numerically differentiable. It's just from the car point of view, it indicates different categories of car designs. So that's why I say, you know, what do you gain from treating it as categorical is mostly from the modeling stage. In data exploration, it's safe to treat it as an integral variable as well. Also, the correlation analysis, also safe. So that's what I wanted to say. All right, I think I will need to speed up, otherwise I wouldn't be able to finish all of these. Okay, so especially straightforward questions will speed up. We'll spend more time on complex questions. The third question because there are missing values, yes. Look at the missing values of examining existence and number of missing values in each column. So when you look at missing values, you start with my MPG that is null, or an alternative version is NA. Be sure to use in both method. Either of these will get you exactly the same thing. So you don't need to worry which one you use. Just go with the one that you like. But what it does is it compares every value with the missing value, and then returns a data object that is the same shape as my MPG. So it's like a comparison clause with a scalar value, right? So in order to get a summary, you will need to do something about it. You will need to calculate. You want to know whether or not there is at least one missing value in this column, and this column, and this column, right? Or if there's a way to aggregate the number of missing values in each column, then that's also another good objective. A good approach. So the sum function is good. We typically do this. Sum. To call sum once on the data frame, it's going to sum over the rows for each column. Rows and columns carry different information in data frame as in data science. So when you do for any aggregate, for any aggregate function methods here, mean, median, sum, or anything, it's going to calculate the statistic for each of the column. So sum is going to sum and basically counting the number of truths, which means the number of missing values of each column, and report that number by column. So this is actually what you want. This is what the question asks for. One level of abstraction. However, if you don't suspect there are any missing value, you just want to recheck. And if there are a long list of variables, there's no point to waste that time. So you can do two levels of abstraction and aggregate to calculate the total sum, the grand sum of any missing values, and there are 6. And we know that all the 6 missing values are in the horsepower previously, but to double check on that, you can use one level of aggregation. You can get a clear sense of that, right? And so this is one command by doing the whole thing. Does it ask us to refill the missing? No, refill is the next one. Refill, I will not say too much on this. This is quite straightforward. Just make sure that either you assign it back to if you replace by column, you assign it back to column. If you fill in on the entire data set, you assign it back to the original data set, or you call the in_place parameter to be true. Then it will replace in_place, but there's no need to assign back. Okay, so I'll leave that to you to finish that last step. Okay, let's question 5 is by using this package, by importing this package. So from matplotlib, import pyplot as PNT, and then also enable interactive plotting. And this is where you would use the magic command here. Start with the percentage. Is the matplotlib magic? Involved? No. I thought it's not so directly. I might be wrong. I think is no. Okay, yeah, maybe I don't have to spell both of them, but this will do. All right, so all the plots will be interactive. Question 6, use the, oh, I will have to fill in the missing. Anyway, so I will do that. I will use this more targeted way. They use the data frames fill in a method to replace. So the question is asking to use the data frame. So I should not use the column. Use the data frame, call the fill in A, and then I prefer to use dictionary because it allows me to be more specific, to not replace value or replace missing values unintendedly. So I will give the target, is the column, is the horsepower, is a key here for the dictionary. Only for horsepower, replace fill the NA with something. Fill the NA with something, with a statistic, and then I will need to get here. It asks me to fill with the mean value of these statistics. Use this method to fill the missing values of horsepower with the mean value of those non-missing values of this column. So I'll first need to calculate the mean value, okay? Horsepower mean is by invoking my mpg dot horsepower dot mean method. I will get the mean value, and let's print that out. We're calculating, and then I will call the fill in A. I will specify this dictionary of the filling mechanism. For horsepower, I'm going to use horsepower mean to replace any missing value in that horsepower column. So this is the complete. And then after that, I will recheck the missing value status. To make sure there is no missing value. Now, since I suspect there's no missing value, I'm going to calculate the grand total of total number of missing values. Yeah, works. First of all, we get the mean value of horsepower is close to 104. Expected, we see numbers 150, 120. So some of them might be below 100. So the mean is close to 104. 104 is used to replace any missing values in horsepower. After that, it's verified that the data frame, after the missing value being filled, there's no missing values. Okay, so with this data set, I'm going to do the rest of the homework questions. Question 6 asks me to use this modified data set and use the function in Python to draw a histogram. So the graphing codes follow almost the same structure. So I'm not going to show it here because it requires a lot of typing here. What I want to do is to kind of spell out the steps. I'm going to use this. No, that's not. Use this triple quote to list my hints here. So step 1, get the column. All right, this is what the modules, how the module does. The first thing is to get the column, assign it to something easier to access. For here, horsepower, you can say horsepower column or horsepower data. That's the first step. Step 2 would be to make a new plot figure object. And then specify the size. So the benefit of doing this in making every graph is that because it's interactive, if you don't make a new graph, it's going to plot your new plot into the previous graph, which makes it less readable and then totally confusing. You don't know where the graph went because it actually was overlaid to the previous one. So always create a new one if that's intended. Here, you want to create a new figure to hold this new plot. So create a new figure, and then, by the way, specify the size. Step 3, make the plot. And then other steps, or modify or customize, adjust or customize the labels and title of the figures. So all the visualizations in this course will follow this format. So if you follow that, if you have the codes examples ready, you can copy and paste and then, copy the right version. Of course, there's histogram, there's scatter plot, there are different versions. Copy the ones that are appropriate, and then adapt the codes. So because it takes more time to do the graph codes here, I'll skip those. And that doesn't affect the other questions. Using this data again, use the functions in plot the scatter plot, same thing. I will put the instructions here, do the same thing, follow the same steps. All right, question 8 is a little bit more involving and also interesting. So here it's about binning. Sometimes we need to categorize a continuous variable just to learn more insights about it, because sometimes the values of a numeric variable doesn't go, it doesn't always very linear in a way, if you know what I mean. Hard to describe very abstractly without a context. But anyway, so what we want to do is to put all the cars into 2 buckets, 2 bins, a high MPG and low MPG, and then try to do more analysis and see the correlation between cylinders and, oh, wait a minute, maybe horsepower and MPG. If we do a scatter plot between number of cylinders and then MPG, maybe we can see that correlation a little bit. But the problem here is that the cylinders is sort of like a discrete value variable, right? It has five levels, 3, 4, 5, 6, 8. And then if you use that as part of the scatter plot, let's say the x-axis, then you're going to see the dots aligned in straight lines, in 5 straight lines, as if they are in 5 buckets, because cylinders are a discrete value. Its numbers doesn't have big variation. So a scatter plot like that with dots aligned in lines, in vertical lines, it's hard to see when there's overlaps because of less variation in X. So scatter plot won't make too much sense. So to see the correlation between cylinders and MPG, it's better if we treat cylinders as categorical and then treat MPG as categorical as well. To do that, binning is the solution here. So we will convert MPG into dummy variable. And then for here, dummy variable makes sense. And also because of the different combinations, we have 5 cylinders. If we have 2 conditions for MPG, we have 2 by 2, 2 by 5 is 10 groups already. It's already a lot to see the bars with the clustered bar charts. as a standard solution to look at correlation between two categorical variables. If we have more than two categories for NPG, then we're gonna have more categories. It will be harder to keep track of and to interpret the graph. But anyway, let me quickly. So to make it to bin, follow a standard process. The first step process is to define the bin buckets. Is to define the endpoints. For two buckets, you need 3 endpoints. And then you want to make sure the beginning and ending are sufficiently far away from, or sufficiently large enough to not cut off the maximum minimum values. And quickly take a look at the maximum minimum value of this is MPG. The minimum value is 9. The maximum value is 46. So 0 and 50 will be good for the purpose. So 0 and 50 is the endpoints, but in the middle, we will use the mean. And the question tells me the mean is this, and it's confirmed up above. You know, take a look again. MPG mean is 23.515, very close. It doesn't really matter if you use 6 digits or 4 digits, it's all going to be same outcome. But anyway, so once we have the bins, we also need to have the labels. So how to name the category level for those that are high MPG. How to name, what name do you call that? The bucket, the bin. You need to give them the labels, bin labels, and 3 cutoff points, meaning there are 2 labels, 2 bins. So you should only provide 2 bins. The first bin is the lower end, so it's low MPG. The second bin will be the higher end, will be the high MPG. With high MPG, that means high fuel efficiency. That with the bins and bin labels, you're ready to cut using pandas method, pandas function, cut the column, provide the column, my MPG, the MPG, provide the column, provide the bins to be sure you want to specify this, even though I know that the order is correct, but to be sure, spam out the parameter that you are assigning. We have bins and labels. MPG bin labels. Okay, so this is going to be complete, and don't forget to assign it to something. Okay, here is interesting. What do you assign it to? Do you assign it to the bin, the MPG bin? So what is this? I know what this is. Let's run it. It's going to create a series with high and low MPGs. It kind of follows the natural sorting. But anyway, it's a series. If I assign it to MPG bin, what is this? It's a series, but it's a freestanding series. It's not attached to any data set. I want to add it directly to the data set. How do I do that? What's the best practice? Should I use merge?
Quotation on the list and bracket.
The question asks to make a new column in the original data frame that is equal to the bin column for MPG. So, Hani, what do you think? How would you do?
Brackets is what my MPG brackets and the bin, the MPG bin between quotations. So defining a new column.
So, yeah, exactly. So what you want to do is bracket and quotes, and then as if you are slicing this column called MPG bind, but this column is not there. If we confirm, I haven't run the last line yet. I only run till here. I just added this, so it's not run yet. If you look at the columns of MPG, of my MPG, there is no MPG bind, right? So what we're doing here is we're referring to the MPG bind, the column that isn't existent yet. We refer to it, and then we assign something to it. So what it does is it will create a new column with that name and put the content into it. If everything works, then the column is created. However, if there's an error, then this column is non-existent. So it's created only if it goes successfully. All right. So if that's the case, can we do this then? Can we use dot method? Since we can use dot method to select the column, which then selects the entire series. Can we do this? The answer is no, you can't do that because dot method is prohibited from being used to assign. You can't assign column. Use that, but the slicing method, the formal slicing method for the column can do. After that, we have the bind column. Okay, let's take a look, and now I can use the dot method to take a look at a few rows. You know, look at the tail, they are high MPG. All right, so the second part of the question is basically now, because we have the high or low MPG, we have the number of cylinders, and every car will fall into this 2x5 10 combinations. There are 10 different unique combinations of the cylinder and MPG high or low. Each car will fall into one of these 10 combinations. So we will get statistics on how many cars do each of the combinations have. What we want to see is as we look at different values on one dimension, how does it change? Then we can interpret the correlation between the two variables. So to quickly show that, first, we want to use group by. What this group by does is it aggregates statistics of different groups. So my MPG group by, if you use, you have to specify the by parameter, and by what columns, by the values of what columns would you like to create groups? By using these two cylinders and MPG bind to create groups. So after that, any questions, says don't forget to specify group by. Don't forget to specify as index is true to make sure you have the columns. As index is false. You don't want them to be indexes. And after the group by is invoked, you have the groups, but then you need to calculate the statistic. The statistic is the number of cars, which means the total size of the subset. So what I get by the end of this is this, you know, a nice data set that overlays the different combinations of the values of cylinders and MPG bins, and then it tells me the number of cars that fall into each of the combination category. And once I have that, I believe we want to save it using this to create a data frame and use it. And we will use this data frame. So this is, let's say, this is the cluster bar data frame, and print that. And then we will use cluster bar charts data frame. Excuse me for a second. Excuse me. Okay. Going back to, so, all right. Once I have the data frame, then we will use the, we'll use this data frame to make the scatter plot. But before that, we will need to make the pivot. The pivot. So what we have here is based on the two values of the two categorical variable, we know that. But for the cluster bar chart to work, you need a pivot table. A pivot table is different from this table when you have only the value as it counts. And then you have rows and columns that categorizes the data into different dimensions. The rows and columns should refer to two different dimensions. So that's where the pivot table comes in. To invoke the standard pivot table, or it's called pivot table as we know it, but the command is pivot, not pivot table. So be clear on that. When you have that, you can call the pivot, and notice there's a pivot table, but that is the other process. What we want is a pivot. And here you need to specify three parameters. There's an index. The index is the rows. What will be the rows? We need 5 rows here. The 5 rows represent the 5 different values for cylinders. So the cylinders column will become the index. The columns will be the MPG bins, the 2 different bins, and then the values, we will use the size. So it will nicely give us a pivot table here. And then I will need to use this pivot table to make a graph. So we will need to first save that pivot RDF. So this is closer to what we need. It's a pivot table. And then lastly, we will need to use to do that and invoke the graph. So, follow the same steps as making a graph. The first step is to create a new figure. The second step, here, since you have the data set, you don't need to create a column or create the data. You already have the data. The first step here is to make a new figure object, and then this is the step 2. Step 2 is to make the chart. And the cluster bar chart is very easy, I believe. So every data frame has a plot method, and then after plot, you have different ways of plotting, and the bar chart will invoke whatever the bar chart structure is appropriate. Since we have a pivot table here, it will invoke the cluster bar chart here very nicely. Once you have the pivot table, you know, it will be a piece of cake to do that. Now, part of that question is also to interpret. Maybe it's the next question. Okay, so assuming, and then these would have to be the binning. Group by would be the second part of the question. So we'll move over to here after the second part. Okay, and then the next question asks you to interpret. Based on this cluster bar chart, interpret the chart and explain the relationship between the two variables. So the way you interpret a cluster bar chart, first of all, you notice that some of these bars are very short. For the time being, you can, when you interpret the basic pattern, you can skip those. Look at those that have more data. And then understand the two variables, the x variable. Now, of course, when you make the graph, you will customize the labels here. These labels should make more sense. This is the number of cylinders in the car. This is number of cars that qualify, or number of cars in that category. And then these the two colors represent low or high MPG. Blue is low, orange is high. So when you look at the low values of one dimension, the cylinders, when the cylinders are low, 4 cylinders, you see that there is a higher concentration or percentage of high MPG cars. When you switch over to higher cylinders, 6 or 8, let's look at 6. And you see a reverse pattern. You see more concentration on low MPG or low fuel efficiency cars, and more so even on 8-cylinder cars. You have even higher concentration on low MPG. So that means the correlation is negative in a way. When you increase the number of cylinders, MPG reduces. When you reduce the number of cylinders, MPG increases. So it's kind of a negative correlation. One goes up, the other goes down. Yeah, and even with the less frequent, less obvious cylinder categories, when you increase the cylinders, the concentration, it's actually the other way. So that speaks to the unique design of these cars. When the cylinder is low, you have lower MPG. However, it's also important to note that because the sample size is small, it's harder to interpret these patterns with only a few cars. So that's question 9. Let me see. Oh, since we had a question here. Chewing had a question on question 10, 11. There are missing values, so I'm going to go through that. But question 12, I'll leave it to you. I want to quickly move on to the exam. Question 12 and 13, I'll leave it to you. Mostly, there shouldn't be too much issue here. For question 10, we'll run this. You get 2 data frames. Both of them have 5 rows. Notice that their indexes have some that are the same, but others that are different. They have different row indexes on some of these rows. And column label are also overlapping but different. You have a P that's the same, but YTH or ON, they are in different data frames. So this is going to impact the different ways of joining. Question 10 is about join. Join is merge. Question 10 asks for a left join. A left join with _1 data frame. It's going to retain the rows and row indexes of the first data frame. And then it's going to look for the same, here, it won't go with those row indexes per se, but these row indexes will remain because it's the left join, and this is on the left side. The question asks to use column P as the primary key, so it will match those rows with the same P regardless of with the same P value, regardless of the row indexes, right? It's going to inherit the row indexes of here. So which are the rows that will be merged together? Those with the same value of P, A0, A10, A20, A20, but not for A50 and A60, because these values are not in the left-hand side data frame. So these two rows will be omitted. And looking at the columns, all of these will be retained because these are in the left data frame. But, and the P is the primary key column, it will not be duplicated. In terms of columns O and N, only those rows with matching keys, the first 3 rows will be merged with column O and N, but for these two, the primary key is not found in the other data frame, so these will be missing. So you expect to see 4 missing values, and everything else will make sense. So let's quickly take a look. So for merge, you should call the merge method of the data frame, and then specify a few things. How is the method? How is the way of merge? It's left. On is when you have a common key. Otherwise, you should do left on, right on. When the primary key used on the left and right hand side are different. And then it asks you to validate, or maybe we should always, as much as you can, validate it's one-to-one matching. And then after you do that, it should conform to what we think about. And the question also asks, the question didn't ask for anymore. It asks you to assign it to my df10. So after confirming the results, it goes by Python naturally. Very nice. It has 5 rows. It doesn't have missing value all the way until column O and N for the last 2 rows. Otherwise, it all makes sense. Python 0, Python 10, not Python, actually, Python 10, Python 20, and then only up to H. To finish off my df 10, and then it's always a good idea to print or just get the outcome just to make sure the result is intended. All right, lastly, Chuan have a question here. So understand the question first. It asks you to do a union append. Append is where you put data frames row after row. You know, it's vertical concatenation. And then it's a union. Remember that when you do append, you can use the data frame append method. Append will always do union append. It will always include all the columns, and there's no way to do other kinds of append. There's no way to do only the intersecting append. So for union append, feel safe to use. It's safe to use append, but for intersecting append, you would have to use concatenate or concat. Pandas concat. All right, so here it is straightforward. If you do df1 append df2, and then let's see, df1 append df2, it's quite straightforward. And then, quickly take a look. It's Python. It's Python. If you put all the columns in the same data frame, it's Python. And then the first data frame go first. Because it doesn't have O and N, all the values of O and N will be missing. And the second data frame goes second because it doesn't have YTH, and all the values under YTH are missing. Everything else are, kind of copied here. Question also asks you to make sure the columns follow the same order. Python, it just follows naturally Python. But just in case it doesn't, what you can do is to, after you get this is my df11, after you get the data frame, what you can do is use the column slicing method to specify the order, so you can do Python, etc. I'm just too lazy to type here, but finish off with Python. But I want to show a trick here, a shortcut to do these. But the point is to put the columns in the exact order that you want them to be sliced, and then assign it back to the same. It will rearrange the columns as you want it. And here the trick is that I use Python, but this is a string, and I convert it to a list. What I want is a list. So I use a string, typing wise is easier, and then I convert it to a list, and then it's good. I know that this will print Python IDF11, but if I simply move n to the beginning, then I get n at the beginning. So this method is very user-friendly. And lastly, you do expect to see the missing values here, and it's fine. Any questions? So everybody's fine. Great. Let me quickly talk about the midterm exam. Since next week we'll have midterm exam, there is a practice exam on Blackboard on the exam page. Feel free to use it to practice, but do read the notes here. The precaution here, this is by no means an adequate preparation for the exam. It just, conveys some of the information, makes it easier for you to be familiar with the exam format, but expect more questions on the exam. All right. What I want to emphasize is that what to do when you start. When class starts next week, join the class as normal, 6 o'clock, and then exam will start shortly after people join the class. And then I will enable the exam. You will see that. You will then download a zip package. The Blackboard exam page will say a few instructions what to do. After downloading the zip package, unzip into a folder, and then go into that folder and move everything, including the Jupyter notebook and the data set, and the documentation text files into, there's no text file, but there is a picture. There will be 2 pictures there. Anyway, move all 4 files together into your Jupyter notebook directory as you would do with any homework. And then launch your Jupyter notebook, start that exam Jupyter notebook in Jupyter notebook, and then start working on exam. After you are done, make sure you save, backup or save the Jupyter notebook, close it, and then find that in your system, Windows or Mac. Use that file to submit to the Blackboard. You don't have to submit anything else, just submit the Jupyter notebook. Now, as you start, the first thing you want to do is to modify your name. You know, exam 1 space your name, the same way that you would do with any homework. You will have 2.5 hours to finish the exam. It's more than you need, most likely. It's more, but I want to make sure you have enough time just in case. Yeah. And a few notes here. Read requirements carefully. These will look the same on the exam, so you don't have to spend time there to look specific, to look carefully. You can read ahead of time. And then make sure you put your full name and the date, the next week's exam date, as a signature to indicate that you agree with these terms. There will be conceptual questions that are mostly multiple choice questions, but occasionally there are multiple answer questions. There's something wrong with some of these choices. You don't want to choose them. So, you know, here, date for crisp DM phases, EDA is not a phase. EDA is a task. So you don't want to choose A, and by that means you don't want to choose E as well. But both B, C, and D are correct phases. So you want to do B, C, D. If you choose E, then that would be more points taken. However, if you choose A, B, C, D, well, in this case, A, B, C, D is the same as E. Well, let's say if you choose B, C and D, but missed B, then you are only making 1 of 5 mistakes. You could possibly make 5 mistakes, but you only make 1 mistake. You'll only get deducted for very small partial points. Since you didn't choose A or E, you also chose C and D, you missed B, so you're only making 1 of 5th. You're only losing 1/5 of the exam of the points worth for the question. So I try to be very fair and try to give more points as much as I can for the points that you deserve. That's the rule for multiple answer questions. A little bit unique, but that's enough to know. And then for spend some time, practice a little bit about these. A lot of the questions in the exam will be similar to these in format. There will be 2 or 3 lines of questions. It may talk a little bit about the data set, and then a few cells or maybe 1 cell that generates the data. And then, be sure to understand the data set and then do what the question asks. When a question only asks to do something and assign it to a new data frame, MyDF44, something like that, then what you want to do is do whatever is required and then assign it to MyDF44. and then that's it. There will always be something that you don't have to change, that you shouldn't change, but will check your answers. You will run them through, and there will always be something to tell you this is what you expect to get. If you get the exact same thing as what you expect to get, you get the question right. So, or at least almost right. One other requirement in some of the questions is that the question limits your answer to 2 lines or 3 lines. You can't exceed the number of lines. If your solution get the intended result but exceed the line limit, it might be a small penalty, but not too much. So the expected answer will help you a lot in debugging your solutions and making sure that you know, when you do it right, you know you do it right. All right. The Blackboard also has solutions to these practice questions, so I will not talk too much here. And then that's it. That's it for now. Any questions?
How many questions do the exam have?
How many questions in the exam? Good question. I believe there are 21. There are, some of them are conceptual, so takes less time, and not hands-on. Some of the hands-ons are fairly easier, but still, there are some comprehensive questions as well. So there's variation. Any other questions? I encourage you to use the homework in Hack Shop and the practice question to practice. As the TA said in the beginning of the semester, try to go beyond that. Don't feel just enough. Ask more questions, and then try more things, explore. And you'll get a lot of benefits in multiple aspects, in the speed, fluency, as well as debugging unexpected errors during the exam. All of these comes down to how familiar you are with the data that you are working with. For sure, I talked about some techniques that I haven't talked about before. Those are useful techniques that I use very frequently. That helps a lot on my work. But the exam, from the exam point of view, it doesn't expect you to be fluent in those techniques that are out of scope in terms of the modules. So the exam will only test you for those that are talked about and highlighted in the modules. But anything that's talked about in the module could be possibly covered in the exam. All right. There's a week. There's still time to prepare, and I'd like to wish you very good luck and wish you have a good preparation. Practice a lot. Let me know if you have questions. Eva will be able to help as well. Other than that, let's make it a day, and then enjoy the rest or enjoy coding for the rest of the night. Bye now.
Thank you, Professor.
My pleasure.
Thank
you.
Professor.
Thank you,
Thank
Professor.
you.
Thank you, Professor.
Thank you. Good
Bye.
night.
Stopping the record.